Hi guys, we're going to do some chemistry today. We've got a reaction where we're putting zinc metal with hydrochloric acid and we're getting the zinc's going to dissolve and hydrogen gas is produced. So we're asked, if 2.5 litres of hydrogen gas was prepared at that many kilopascals and that many degrees centigrade, calculate the following: the mass of the zinc that's required and the mass of the hydrochloric acid consumed. Okay, so to do this problem, what we're going to need to do is we're going to have to convert this litres of hydrogen gas into a molar quantity. So this here has to be converted to moles. Now, the only way we can do this with these different pressures and temperatures is using what we call the ideal gas law, which is an equation that states the relationship between pressure, volume, and temperature of an ideal gas or a hypothetical gas. So the ideal gas law yields the relationship the pressure of the gas times the volume of the gas is equal to the number of moles of the gas times some gas constant times the temperature in Kelvin. Now this constant is equal to 8.314. So this temperature has to be measured in Kelvin. So what we're going to do first is we're going to convert the 25 degrees Celsius to degrees Kelvin. So the way we do that is this is going to be equal to 25 plus 273, which is equal to 298 Kelvin. Great. So let's get on with the problem. So for part A, we're asked to find the mass of zinc required. So like I said to start with, we have to convert this litres of hydrogen gas into moles of hydrogen gas. So using this ideal gas law relationship, we're going to rearrange it so it's going to have N as the subject, and we're going to write N is equal to PV over RT. And this is the number of moles of hydrogen gas. So that's going to be equal to 103 is the pressure times the volume, 2.5, divided by the gas constant, 8.314, times the temperature. And if you crunch those numbers into your calculator, you're going to come out with approximately 0.104 mole. And that's of, let's just clean that bit up a bit. Mole of hydrogen gas. So what we then do is we have to look at our molar ratios using the balanced chemical equation. So we have here the number of moles of hydrogen gas is equal to the number of moles of zinc metal to start with. So what we do is we go the number of moles. I write this down for the benefit of the teachers, so it shows that you understand molar ratios. The number of moles of zinc is going to be equal to the number of moles of hydrogen gas, which is equal to 0.104 mole. Cool. So, finally, for part A, we need to work out the mass of zinc. So, the mass of zinc is equal to the number of moles times the molar mass, which is equal to 0.104. And the molar mass of zinc is 65.38. And that yields 6.80 grams of zinc. Cool. So that's all she wrote for part A. Now let's just separate it again. Part B. So, the mass of hydrochloric acid consumed. Now, like part A, we're going to use the number of moles of hydrogen gas, and we're going to use it with the molar ratio to work out the number of moles of hydrochloric acid required. So, as you can see, there are 2 moles of hydrochloric acid required for every 1 mole of hydrogen gas produced. So we can say that the number of moles of hydrochloric acid is equal to 2 times the number of moles of hydrogen gas. So, we know that the number of moles of hydrogen gas are 0.104. So we're just going to times that by 2. And that's going to yield 0.208 mole. Cool. So, like the final part of part A, the mass of hydrochloric acid consumed is going to equal the number of moles times the molar mass, which is equal to 0.208 multiplied by the molar mass of hydrochloric acid, which is the molar mass of hydrogen plus the molar mass of chlorine. And that comes out at 7.58 grams. So, you can see there's not that much to the problem. Where the make or break situations occur in this problem is when you see this litres, this volume quantity of hydrogen gas, you must convert it into a molar quantity using the ideal gas law. You also mustn't forget that if the temperature is in Celsius or Fahrenheit or whatever, you must convert it into Kelvin. Then basically, once you've used the ideal gas law to calculate the number of moles of the gas that is produced by the reaction, you just use the balanced equation to find the molar ratios of all the other reactants. And once you've done that, it's quite a simple process of just multiplying the number of moles of each by their molar masses to come out with the mass of each required, consumed, etc., etc. So, I hope this little video helped, and I'll see you again next time.